Oh, hey. Hi. Thanks for watching these videos. Please remember to click subscribe, like, share them with your colleagues, and then click show more below each video. Lots of lesson plans and ideas, inquiry questions, perfect for your classroom. Thanks for watching. Something else that's coming from the sun, it's quite harmful to us on Earth, is ionizing radiation. Virtually every component of the electromagnetic spectrum radiates from the sun. It's really quite a deadly beast. Not only is it hot, but it's got a lot of radiation pouring out of it. And radiation not necessarily just in the form of light and heat, but radiation in the form of alpha and beta, gamma radiations. These radiations would otherwise scramble our DNA if it weren't for the fact that the Earth has a magnetic field. The first discovery made by NASA was the effect of Earth's magnetic field towards the sun's ionizing radiation. They're called the Van Allen belts. And what happens is the Earth having a core of iron and nickel and cobalt, the magnetic elements of the periodic table, generates a field, an aura around the Earth that extends far out into space. Even the astronauts on the International Space Station, who orbit at an altitude of approximately 400 kilometers, are still within the Earth's magnetic field. Now, it's weaker out there because the magnetic field diminishes by the law of inverse squares. So if I'm twice as far, it's a quarter as strong. If I'm 3 times as far, it's a ninth as strong. Are you following the pattern? 4 times further, it's 1/16. This is called the inverse square law. So it does exist out there, but it is weaker. However, what happens is when the sun's radiation heads towards Earth, it meets that magnetic field, causing the stream of radiation to go around us, forming what are detectable as what we call the Van Allen belt. Interestingly as well, on top of that is the magnetic field directs this ionizing radiation towards the poles. And it results in what we call the northern lights, or the southern lights, the aurora borealis, or the aurora australis. I may have said that wrong, australis. But the northern lights come about from this ionizing radiation streaming through the Earth's magnetic field, and where you have this interaction, this mingling of radiation with magnetism, you get light being produced. And the light dances around the perimeter of the poles, both north and south. And once in a while, the sun will have an extra strong burst of energy. Sometimes they're called coronal mass ejections, a CME. And if the coronal mass ejection is aimed towards Earth, the radiation mingles further south in latitude from the poles, or further north from the South Pole. And the northern lights can be seen further down into the southern reaches of the planet. I'm at the 49th parallel, and I've even seen the northern lights one time here, which is very unusual. They're usually typically above the 60th parallel. But this is one of the privileges of living in the far reaches of the north or the south.